This is project 2, video 3, the video in which I do the documentation and finishing touches. So let's, I think I'll get the checklist out from the handout. We got the algebraic description, reasonable attempt at writing the program that works properly. I think I got that. And then here we go, documentation and finishing touches. Get your name in every .m file. Alright. So, percent by Jeffrey Schnick. I'm going to copy and paste that into the other one. I'll copy the blank line too. Where is the other one? Okay. Must be documented for each function. This will include comments starting at the first line after the function statement stating what the function does. So, first line after the function statement. That's the function statement. This is the first line after that. Percent function get R. And here you have to say what it does. So it takes these arguments and finds out where along the line extending from the position of the smaller charge, which is x sub s comma 0, to an empty point in space in a direction that makes an angle of theta with the positive x direction, with positive theta being counterclockwise from plus x direction, from the plus x direction. You have to find out where the value of the electric potential is 0. I think I would think about how I want to say that, but find out where along a line that makes an angle that passes through x sub s comma 0 and makes an angle of theta with the plus x direction, where theta is measured positive counterclockwise from the x-axis. Find out where along that line the electric potential is 0 due to the two charged particles, QB at one position and QS at another, where QS and QB have opposite charges and the magnitude of the charge QB is greater than the magnitude of charge QS. Okay, in other words, you got a lot to write there. You got to think about how to write it and write it carefully, communicate effectively. And then we got to say input variables. So I do that for each of them. So let's go over to the other one as far as the function description. So percent function plot phi 0. I'm not sure that's a good name for it. Hopefully some of you come up with a better name for it than that. And then say what it does. Carefully and thoroughly. So if you're too vague on these things, you won't get credit for the whole documentation because you didn't do a good job saying what the function did. Let's go back to the checklist. So suppose I've written that all out, figured out what that does, and written it out thoroughly. And then according to the checklist, another set of comments. So I was starting to do that for the other function. So input variables. I've got QB is charge of particle having charge of greater magnitude. And then you gotta do XB. It's the position of the particle having the charge of greater magnitude. And so go ahead and write that all out and do the same thing for the other input variables, QS, XS. So this is your job. I'm not going to do it all for you. I think you know how to do it now. In theta, just help you identify what the input variables are, but it's pretty obvious. And then I create a line there on percent output. And there is just one of those. R. And, you know, it's the distance from the particle whose charge magnitude is smaller to the empty point in space measured along a line that makes an angle of, to the empty point in space where phi is 0 along a line that makes an angle of, etc. Alright, and then I gotta do for the other one, the wrong spot there, for the other one, percent input variables, percent, and fill them in, the whole list. There are going to be 5 of them. But this is a little bit different now. This is the charge of one particle, charge of the other. You know, the charge of one particle, the position of that particle, the charge of the other particle, the position of that particle. For this one, we don't know which one's greater to start with. The user does not have to say which one is greater, or it does not have to put them in order, with the greater one being first and the lesser one, or the charged particle having a magnitude of charge less than the other one, second. So, alright, let's pretend like you put down all the input variables, output variables, you explicitly address it, but there are none. So you tell them that there are none. This dummy, the name of the variable suggests that it's not being used, but explicitly tell them in your list of output variables. So then what? What do you have to do? I'm not actually doing it all, just going over what you have to do. List of arguments. Okay, got that covered. Alright, let's look to see if alright, somebody might wonder what the heck is going on here, like why didn't I just use the names that were given? So I'm going to say what we're doing here. Put particle having greater magnitude charge, so that's charge and position, in QB and Q S no XB respectively, so in that order, and then do the same thing for the other one. Oops, Control C. Control C. Control V. Put charge and position by having a smaller magnitude charge in QS and XS respectively. Alright. So that says what's going on there. Here it's pretty clear in creating an array of theta values. Here, if I describe the function carefully at the top, then it's clear what R is. And yeah, I think it's all pretty clear. XB is the position of the charge having greater magnitude, so it's pretty clear. I'm putting X marks the spot for each of the charged particles. I think in this little segment, draw line through y equals 0. Because this doesn't put the axes, doesn't make the axis go through 0, 0. And then through x equals 0. Alright. I think, again, if you got a good description of it, it should be obvious what's going on in here. The axis equal maybe isn't quite so obvious. But if, well, it's a command by itself, so we'll assume people know, can figure that out. Like you don't, they know it passively. In other words, when they see it, they know what it's doing. In other words, people are supposed to know MATLAB well enough when they read this. And then, so I think it's just a little easier to see what's going on with a little bit more spacing in there. Alright, I'm going to do a Control S there. Let's see if the other piece of code needs some explanation. I think it's pretty clear that we're trying to find out what R is, and it said to do that. I think it's actually kind of obvious that R itself is a solution to a quadratic equation based on the choice of the names. So I think that one is self-explanatory enough. Okay. So let's see what else we're supposed to do. They're not self-explanatory, say what they're doing. So I thought it was necessary this time to explain a few things, but not every detail. For the case of a function that produces one or more graphs, each graph must be titled and each axis must be titled with the units in the name. Alright. I think I've actually got the positions of the two charged particles and the locus of points at which potential due to them. Boy, that's a long title. Let's see. I think I'll try titling it, but I don't think I can put everything in the title. Locus of all points, maybe the set of all points. It depicts the set of all points, so set is shorter. I think I'll draw that. So let's see. Title. Set of points. I like that word, locus. Locus of points at which potential due to two charged particles is 0. Let's see what that looks like on the graph. Alrighty. Actually, I think that's alright. Locus of points at which potential due to two charged particles is 0. And it does show the two charged particles as well, but we can only fit it as a title, not a descriptive paragraph. So I think that should be enough. Then I think it's X label. X label. Yes. X in meters. So please use square brackets for this, not parentheses, so it doesn't look like X is a function of something, but this is X and its units are meters. I'm not positive about the X label. Like if that's the right name of it, it could be X title or something. The more I say it, the more sure I'm getting. But let's see, yeah, X in meters and then Y in meters along there. So and Y label, Y in meters. That's supposed to be meters. The close quote goes around the end of the whole axis title. And let's see, I think that looks pretty good. Control S to save it, command window, up arrow to run it again, click on the graph to look at it again. Okay, I think I got the graph titled and I got the axes titled, including units. So just positions and space is all I'm marking off there. Alright, let's see what else we got. It's like more than one plot. I do have more than one thing plotted on there, but I think it's pretty obvious what's what. And I don't, I have like 2 different curves plotted, for instance, so I think we're good. X marks the positions. You might put that in the description, like the positions of the charged particles are marked by the symbol X. I think to stress how important that is, I'll do that. So this is our graphing one. So say what it does. How charged particles are indicated. Let's say depicted in your graph. So you might use something other than that. Maybe you'll use a circle minus sign for one of them and a circle plus sign for the other. It's more work, because you got to figure out which one is negative among these. You can use the if statement to do that. That'd be cool if somebody took care of that. Somebody actually did that. Please do. Be the one. And one more look at that graph. I think that's looking good. So you must provide attribution. Alright, your attribution has to be different than mine. Make sure your attribution is different from mine. I think it's appropriate for me to say I had to look up a bunch of stuff because I was rusty on how to do things, special things with graphs to make things come out right. You can go to those same pages besides just referring to the videos this time. You can go to pages to figure out how to do a little bit better. For instance, if you do choose to make it so that you can tell these apart, for instance, a plus and a minus, or you might choose to make like the negative one a black X and the positive one a red X. Here I just let the colors come up as they may, and you might want to control what the color of that what looks like roughly a circle, we'll call it an oval there. So you might actually be referring to pages as well, but I would expect if you can hear my voice now, then you probably use the video to do yours. So what would be cool if you were just using it as a check, you said I did it all on my own, and then used the videos to check my work just to make sure. But you're going to need some attribution, and I think you're going to have to refer to the videos. Tell a little bit of a story about how you actually came to have your finished product. Alright, I got to check the other function. I don't know that I put any attribution in there. So I think I'll write a message to you here under attribution. Say what resources you used to help you get your code written, and tell a story. Here, I did the pencil and paper on my own. I checked your video. Mine was perfect, and I started to code it up. I got stuck. I looked at video number 2, project 2 video 2, got unstuck, did it all on my own from there on out. And then I looked at it again to check and make sure mine was right, and I did find one little mistake, and I fixed that kind of stuff. Alright, so I got the attribution in there. I think I better save it. That's this one. I better save that one to Control S. So just hit Control S to save it. And then I wanted to see if there's anything else. And you don't get credit if it's the same as mine, so make sure yours isn't the same as mine. I don't see how it could be, since I'm writing a message to you rather than writing actual attribution in there. Or only writing attribution. I did have to do my own attribution as well, because I did use some outside resources. Alright, so I'll just run it 1 or 2 more times here just to make sure everything's working. So I put to the right of the origin, and you can make one of these 33 I mean, and run it. See if it looks a little bit different. Yeah, one of them. This one's much bigger, so the circle's going to be all real close to the smaller charge. That makes sense. This one has such an advantage with respect to amount of charge. This one has to make up for that by distance, so it needs a much smaller distance, and all the points are really close to the smaller charge. Alright, I think that looks good. I'm going to call that a wrap for project 2 video number 3, the last video for this project.